Section 10-2, Part 3. Triangle ADE, the large triangle, is the image of triangle ABC, the small triangle, after a dilation with center 0, 0 and a scale factor of 2. So, triangle ABC is similar to triangle ADE. Similar triangles have the same shape, but a different size. Effects on angles. Angles are taken to angles of the same measure. By them giving us a similarity statement, we know that angle A corresponds to angle A. We know that angle B corresponds to angle D. The two in the middle correspond. And then the last two correspond. Angle C corresponds to angle E. Since we know that these triangles are similar, we know that angles of similar triangles that correspond to one another are congruent. So therefore, we know that angle A is congruent to angle A. We know that angle B is congruent to angle D. And we know that angle C is congruent to angle E. All referring back to the similarity statement. A congruent to A, the second one, B congruent to D, and the third angle, C congruent to E. Effects on line segments. Line segments are taken to the line segments so that the ratio of the length in the image to the corresponding length in the original figure is equal to the scale factor. So, we go by the similarity statement again. We have these two triangles being similar. Now, when we know that triangles are similar, their corresponding angles are congruent and their sides are proportional. Therefore, we can form our scale factor. So, I have listed these out. Since we know that this is our similarity statement, I took the first two letters. AB corresponds to AD. The first two here corresponds to the first two here. BC corresponds to the last two. BC is the last two here. The last two here would be DE. And then last, A and C corresponds to A and E. Now, to write our scale factor, we will always place the original triangle was the small ABC, so we'll take these sides, go in the denominator, all right? Your original always goes in the denominator. So we would have AD over AB. We would have DE over BC. Always taking this one, putting it in the denominator. And then last, we have AE over AC. So let's look at the lengths. All right, we have A to D over A to B. All right? So looking at AB and AD. Then we have DE and BC. We have DE. I can count those. That would be 1, 2, 3, 4, 5, 6. DE would be 6 over. BC would be 1, 2, 3, 6 over 3. This will reduce down to 2 over 1, dividing each one by 3. Okay? Now, AE over AC. All right? AE. Count those from A to E. You would have 1, 2, 3, 4, 5, 6, 7, 8 over. And then AC, A to C is 1, 2, 3, 4. I'm counting my boxes. So from A to E was 8. From A to C was 4. Reducing that, dividing each one by 4, I end up with 2 over 1. Now, you cannot count when it's a diagonal. You cannot count the number of squares. You can only count the number of squares when you have vertical lines or horizontal lines. So when we got the value of DE, I counted the squares. 1, 2, 3, 4, 5, 6, and BC was 1, 2, 3. Then I found A to E was 1, 2, 3, 4, 5, 6, 7, 8, and A to C was 1, 2, 3, 4. Notice that both of these, 6 over 3 reduces to 2 over 1, 8 over 4 reduces to 2 over 1. Therefore, when triangles are similar, sides are proportional. In other words, when you set up your fraction, each one of these will be 2 over 1 in reduced form. Therefore, AD over AB is also 2 over 1. So your sides are proportional. That's what it means. They all will reduce to the same scale factor. All of them will reduce down to 2 over 1 in this problem. In a problem, all the sides will be proportional. They'll all reduce to the same scale factor. And your corresponding angles are congruent when you know triangles are similar.